Welcome. So my name is Brandon Estevez. I'm the director for the National 4-H Geospatial Leadership Team, and I work with Srajan actually here. So our job from the national team is really we're a youth-led team that focuses on kind of empowering students to do, youth-led research initiatives and all types of topics, and really what their passions are. So Srajan, his project is on analyzing banking equity in Charlotte. Mine is on rediscovering and kind of piecing together the humanities in my city with a local project on the state archives. And we kind of have really projects from almost every topic that you can think of, from agriculture, medicine, history, utilities now actually, immigration, almost any topic that you can think of that people are interested in. We have someone working on it. So that is kind of one aspect of the national team. The second part is really this, which is, educational outreach and also trying to teach students on, how to use GIS. So the workshop I'm going to be presenting to you today is on satellites to seeds, and this is a part of our Youth Map Lab program that we're actually starting off this year. So congratulations, you are all the second cohort to actually get to experience and have fun with this entire project and workshop. So I'm excited. We'll basically be walking through few different things. You'll kind of get to design your own farm in GIS. I know this may be the first time that some of you guys are actually using the software, so I'll try to make it as intuitive as possible, and I'm here to kind of help guide you through how to go through the process, as well as Rajan. So you'll design your farm, and then you'll kind of get to see how you can use GIS and AI to map environmental risk, and then finally explore STEM careers in agriculture. So I think most of us here luckily know, what AI is. At its most basic level, it's really just an algorithm is designed to train a computer to think like a human, right? So it can help us in predicting different things. It can help us in automating and decision making. And in context of agriculture and farming, we can use AI really to detect things like plant disease before they happen. We can use it to forecast droughts in certain areas. We can also use it for decision making when we're trying to help farmers figure out where do they need to sell their crops and where does it make the most sense. So that is some of the few use cases of AI. And then what about GIS? So hopefully, since you're in the GIS division, I hope that you know what GIS stands for, but it stands for Geographic Information Systems. So the use case we're actually going to be walking through today is visualizing soil, rainfall, and plant zones across the United States, and you guys will basically get to choose kind of different crops that you want to grow. So I'll make sure to send in one more time in the chat for everyone here. But if you actually go to the GitHub, that should have the access to all the different resources we'll be going over today. Make sure to download either the Word version, so docx file for the student worksheet, or if you want, you can also download the PDF and print it out. The PDF is mainly intended for when we do this in person, but you're more than welcome to. So I'm going to go ahead and kind of walk through mapping the future. So on your worksheet, it should allow you to select the crop that you want to grow. You can either circle or just write it down somewhere what you're going to do. And then I actually want you to open up the Satellites to Seeds map, which is the second link. This one should bring you to this page. And from there, you're going to hit Open in Map Viewer. And it should take a second to load. And I can actually open it up for how it should look like for you guys, like this. There we go. So without an account, you don't actually have to make an account. You have to sign in. All this content is being provided for free by us, by the national team folks. So you'll kind of notice that the map is currently blank, and that if you hit this square icon on the top left corner called Layers, it'll basically show you all the different data that we've already gone ahead and preloaded for you. So for our example, I want you to go ahead and kind of find the one that says North America annual precipitation, and then hover over this eye icon, and then just tap on that, and then you'll be able to visualize North American annual precipitation. And obviously, I don't really know what these numbers mean yet because all it is just colors. So the way to kind of figure that out and get the legend is by tapping on this tab over here that has 3 lines and a few squares at the end called legend, and that'll show you basically what the key is meant to represent. So I can zoom out a little bit and kind of see the entire extent of this map. Just as a general question, what are some of the relationships you guys immediately see? And anyone can answer.
I can also notice that in the more East Coast, there's far more precipitation than the West Coast, probably due to like the weather patterns. Yeah.
Yeah, no, I definitely noticed that too. You can definitely see the bigger pattern is kind of here towards the south near the Gulf of Mexico. Um, so yeah, obvious. So that is kind of a quick run through on how Map Viewer works. You can turn on and off different layers. There's a base map and the legends, and those are really the three features that we're going to be using today. So within your worksheet, it should give you the option to go ahead and figure out where we're going to basically be role playing being a farmer. So what are the kind of four things that farmers really need in order to, grow crops and be successful? Does anyone know?
Sunlight,
Yes. Would be helpful to have sun.
water,
True.
Healthy soil.
nutrition.
Both are correct. Soil.
Is 4-H Spirit one of those?
No. uh, in your worksheet, it should give you the option to kind of go ahead and figure out where you want to plant. Because we're doing this online, you actually have the option to use Map Viewer for this. So you can kind of go ahead and turn on the soil crop layer, and it'll render hopefully very fast. Depends on your machine. And I'm actually going to turn off, go back to topographic. And in case you don't understand what the different or what the colors symbolize, you can always just look at the hit legend, and you can look at the metrics and immediately visualize where are the best places for planting. So what I'd invite you to do is when you find a spot, I'm just going to select this area off the Pacific Northwest. You can hit this icon on the right sidebar called Add Sketch, and it'll allow you to put either a point. You can either draw a polygon, which is what I'm going to do here, and from there, square, circle, add text, etc. So your feature name, you can go ahead and name it. I'm going to name mine a farm. And then I would encourage you to enable pop-ups like that. Put a title, so put farm, and then you can add any other text. This is where I'm going to grow and then you can put your crop there. And then hit OK. Boom. So now when I click on this point, I now have a geographical feature that shows me, what area I'm studying per se. And the reason I did that was because what if I also want to make sure that this place has great soil content, but what about, what I can actually grow here in terms of USDA hardiness zones. So let me see if it'll load. I'll play around with precipitation in the meantime. So I can see that there's definitely a lot of precipitation in this area. Let me turn off the pop-up. And if I turn on the legend, it's close to 3,000 and almost 6,000 millimeters annually of precipitation, so that is quite a lot. And then the last thing is you want to also analyze the plant hardiness zones. So I accidentally included mine in the Canadian extent. So if you select within the United States, it should have the data from the USDA. And this is all based on plant hardiness from the USDA's own indexes of what grows where. And we'll come back to that in a second. For now, don't worry too much about the natural disasters data that's loaded in here. But yeah, I'll kind of turn it over to you guys to kind of play around with that for a bit. And feel free to ask me any questions. First of all, congrats. You guys just did something that people get paid like millions of dollars to do for a lot of the world's leading ag companies. Granted, Sachin and I can both tell you that there is a lot of ways to make it a little bit more complex and mathematically figure out the best locations. But with this kind of visual layering example, we kind of achieved the same result. So I want to move on to, man, messed something up on my side. There we go. To kind of the next part of your worksheet, which talks about disaster striking. So actually hurricane season just started a few days ago. But your map that I gave you as an example also includes all that disaster data that I told you to kind of ignore for the time being. So we don't actually have disaster cards because those are designed to be for our in-paper sessions. But for sake of example, just decide if you want to do hurricanes or if you want to do floods. So within your map viewer map again, you should have the option to see at the bottom recent hurricanes, drought intensity, and flood hazard areas. All of this data is compiled from the Federal Emergency Management Administration, or FEMA. along with the National Weather Service. So I can go ahead and turn this on, and I will warn you to only load one layer at a time, just because it can be a pretty heavy layer. Man, that didn't work. Oh well. So this is for drought intensity. Shows you that currently some parts of southern Georgia or southern South Carolina and on the coast of North Carolina are facing droughts. And you can see where droughts are hitting the west the worst. Mostly this area near the Rio Grande River that divides Texas and Mexico. I can also, for flood hazard areas, this shows you areas that are prone to in the United States to flash time floods or just regular flooding from a certain amount of precipitation. So this criteria and these maps are actually used by FEMA to assess whether areas are in danger or need to be evacuated when there's storms coming in. And that's also why you get all those different flash flooding warnings from the National Weather Service. It's because an AI model has been trained to basically recognize if there's an X amount of precipitation hitting this area, then it needs to warn people within this geographical extent. So you're actually looking at a data set that powers those alerts. So I'm going to zoom in on Raleigh just because that's where I live. And you can kind of start to see all these different polygon layers. Oh, whoops, there we go. But it shows that for the most part, flood risk is closer to tributaries. And if you want, you can hit on legends, and it shows you, what areas have a 0.2% annual chance of flood hazard. So obviously very low, 1% for, slightly higher. And then this is actually mapped using machine learning based on the next 10 to, I think, 15 years, what the National Weather Service estimates those areas will begin to be part of that risk area that may be flooded now. And the area was reduced risk due to levee is compiled in cooperation with the U.S. Army Corps of Engineers. And I don't know how familiar you guys are with levees, but they're very basically just dams next to rivers designed to prevent flood water from actually entering cities and towns that are in low-lying or flat areas. So if you scroll to the coast, you can immediately see that there's obviously a lot more flooding risk when you're closer to the ocean and when that elevation is very, very close to sea level. Compared to here in the mountains where the threat is almost non-existent except next to the rivers. Not to say that that flooding will never happen to them, it's just that they have lower risk. So go ahead and kind of evaluate the location that you chose and see if you're at an area or in an area that's near one of these natural disaster threats, and then how would you mitigate, moving basically your farm operation, or if you're gonna, brave the storm. I wouldn't recommend the latter, but who knows. So I'll take the next, let's do 2 to 3 minutes for you to kind of play around with using these different data sets. And I'm, again, happy to help or answer any questions.
Brandon, this is like a general question, right?
Mm-hmm.
How do you find the data sets to begin with?
How many, sorry?
How do you find the data sets?
So, for them or for us?
Just in general, like for them.
So for them, you would go to livingatlas.arcgis.com, and I can actually paste this link and send it in my email later on today. But if you guys are curious and want to see what other data is out there, this is called the ArcGIS Living Atlas of the World, and it is a collection of everything geographical that you can think of. So you can actually hit browse up here at the top ribbon. Oops. And it will bring you to basically that database. So you can view the data set, all of this data for free. You don't need a software, you don't need an account. You can do this completely from the website. So you can view different base maps. So base maps are just like, what's underlying under all the data. So like streets, satellite imagery, etc. You can also look at different types of imagery. So satellite imagery is something that I'm still getting introduced to. But if you wanted to learn more about, imagery that the Department of Defense uses for estimating where nuclear warheads are based on UV stuff, that's where you'd find that. Or if you wanted to see, different color bands, what areas are more green for whatever reason. Most of the time that's usually for estimating parks. All that great stuff. Imagery tab. Boundaries is for anything. It's mainly 3 categories: administrative, environmental, and geometric. The people tab, which is where a lot of our research projects actually get their data from. So everything from population to neighborhoods to spending to health. And then finally, infrastructure, which covers pretty much everything that the government builds, which is transportation, traffic, structures, utilities, and in the last two categories, business and agriculture. The environment is pretty much anything that you can think of that relates to the natural sciences or to life sciences. So earth, oceans, elevation, topography, energy, all that great stuff is stored under that tab. And the nice thing about some of these actually is that they're actually live data. So for example, the Sentinel-2 views is a live data set from a NASA satellite. The USA current wildfires is reported from, I believe it's the US Forest Service that actually reports most of that data. This data set on alternative fuel stations is reported from the EPA. Current weather and wind station data is provided courtesy of NOAA. So all of this great stuff that you can just kind of look at or use in projects that you're working on. It just adds a much more real and authentic feel to the stuff you're doing.
Is there ever like a situation where the data sets are like conflicting?
I guess describe conflicting real quick.
I mean, like if there are two reputable organizations collecting data like about the same topic and their data slightly differs in any way, is there like what does the software do?
So for the most, when you have the way ArcGIS works, let me back up. In your map, right, you have these things called layers. That's basically the base of how ArcGIS does its analysis and does its visualization. It's you have different layers on the map, and you can turn them on or off, or play around with symbology or do analysis. So if you had that example, let's say we had two. I'm just going to take the flood hazard area data set I have loaded up here, right? For whatever reason, FEMA came up with it, but so did National Weather Service. That wouldn't really impact the software as much as it might impact your understanding. Like, it would basically be up to you to figure out which one's more authoritative based on the documentation that's provided for the data set and which one's more up to date. For the most part, though, I will say it's been very, very rare. I don't think I've ever found a data set that really conflicts with each other from the same year. Strajan, have you? For the business projects?
Use what?
Have you ever found like two data sets that conflict with each other?
Yeah.
Oh.
I found one for I had to make my own, but on the City of Charlotte Open Data Portal, I did try finding a financial institution layer, and that had banks, like any insurance company, really anything you could think of for financial services. But then on that same data set, it also had things like grocers or independent stores, which I didn't really want to include in my data set, so I had to go make it my own with business analyst. So there's like little things like that that kind of conflict with each other, but yeah.
Yeah. And so what Rishabh's talking about is the open data portal that your city actually has on all this wonderful data that you can also use. So I think it's been a few more than 3 minutes I originally promised, my bad. So kind of just let's share out what you guys learned about, what your flood risk or hazard risk was, and how did you mitigate it?
So should I share my screen?
Sure. Go ahead.
Okay. Probably have to do it from here. Yeah, there we are. Okay. This one. Okay. So I picked this area kind of shielded by the Allegheny Mountains. And it definitely protected it from like the storm, the worst of the storms, because
Yeah, mountains.
So I don't know why some of the layers aren't working on this. I'm using my my main computer that I showed you earlier.
Mm-hmm.
And I'm checking the layers there. And I'm trying to like sort of base it on landmarks over here on where it's going because it's not being impacted by hurricanes that much. The drought is like just barely out of this area. I'm guessing the mountains have something to do with that.
Mm-hmm.
I'm not really sure. Maybe the mountains are sort of like cooling the area.
Might be.
Maybe.
Also, just wind patterns might be affecting it. Good conclusion, though. I have no idea. I'm guessing too with you.
Yeah, and then
Flood
flood hazard. Please work. No. Okay.
There we go.
Yay,
Ouch.
okay. Oh shoot.
Really picked an excellent plot of land.
Uh-huh.
On the bright side, you won't have to worry about irrigation.
Mm-hmm.
All right. So what was the solution you came up? Oh, go ahead.
Maybe it's. Sorry.
No, I was just gonna ask you. So what was the solution you came up with? Did you want to protect the farm, or did you want to basically move it?
I guess. Let's see. How big does the farm need to be? Because if we just like sort of trim off this bit over here by this spike. Hang on. Let's see. Does this work? No. Is there an annotate tool? Just draw. Oh, rectangle selected. That should do it. Okay. Can you see this?
Yep.
Yeah. Maybe if we just, I think this box I'm selecting here is like that's where all the flooding is.
Near Clarksburg?
What? Yeah, Clarksburg. So we just sort of, let's see, do something like this. No, that's like half my farm. Can I stop please? Okay. Maybe something like this. Okay.
So kind of along the basin, almost in a way.
Yeah. Just keep all the good farmland and
Reduce all of your risk from the flooding there.
Right. Just move the crops from over here to not over there.
All right. Good plan.
Mm-hmm.
Does anyone else want to share out?
Right.
Yeah, I can check.
Sure. Go ahead.
Right.
Oh, I'm still sharing. Okay. Stop
Yeah.
sharing now.
Okay. So down here is where I first had it because it had good carbon density, rainfall, all that. But then there's a lot of flood hazard. If I turn on the drought conditions, it gets in there too a bit. So I just decided to completely move because here it still had good precipitation. It's in a good spot. There's not much flood hazard. It's a big area. I have to narrow it down. But there's not really much flood hazard except for this one spot.
Yeah,
And
top peninsula, right there.
Yeah. No drought intensity at all.
Oh wow. All right then.
I can share mine.
Sounds good. Good deal. I'm now
Great.
just. Oh, go ahead.
Hold up. Yeah, Ishan?
Oh, I was raising my hand to like share mine.
Oh, sure. Yeah, you can go.
Okay. I'm not gonna share my screen because mine is being really laggy. Like I can't like move at all. I don't know why.
Okay.
But I'll just tell you guys. I like observed that mine was particularly safe from flooding, and I presumed it was because I picked like a more natural area. Like there was a lot of like tropical rainforest and like forested areas near where I picked, and that I'm assuming that's what like reduced the flooding risk in the area. So like I just like tried to aim for more natural areas or like move into more natural areas because those have less of a flood risk.
Awesome. All right then. So that kind of concludes the activity portion of this. So I wanted to turn back towards kind of talking about. Great job, everyone, by the way, just right out of the box for going ahead and using the software. I will say you kind of picked up on a lot faster than I did my first time. So what are some careers in kind of the industry that you were just exploring, which is smart agriculture? Well, for starters, you could work as an agronomist for academia or industry. A lot of big ag companies have someone on payroll that their entire job is basically to just watch trends in agriculture and really technology with how they can address, the different things you guys were just analyzing. So, natural hazards, weather data, all that great stuff. You could also, the skills that you were using tie into being a GIS analyst. So the software or the website I gave you is an ArcGIS map viewer, and it's just one of the, I think, hundreds of products that another company called Esri has for different industries, almost everything that you can think of, from defense to utilities, transportation, logistics, governments, nonprofits. All of them use this type of software to help them support their businesses or services. You could also work as an AgTech developer. So I'm working right now on with LabCorp and Biogen on coming up with some solutions with the ag research projects that we have, and kind of trying to figure out how we can integrate that with the GIS components that we have, that our team brings. You could also work as a climate scientist for the EPA, USDA, or any university. Those people are going to probably be in demand for a very long time, unless the climate gets a whole lot better. And you can also finally work as a sustainability officer. You could be someone that's basically their entire job is to just see what's the best way to kind of cancel out carbon emissions, but also to market products in a way that is environmentally conscious and towards those consumers that do want products or services that are, environmentally negating their effects, right? So my last slide for you is really kind of sharing out your farm design, which you kind of already did, so I'm going to kind of skip that. But I really wanted to reflect on what you learned and invite you that if you're interested in GIS and all the software we just used, there'll actually be an opportunity starting I think next school year potentially, for you to earn high school credit with another program that we're working with called Spark NC. So if you're interested in that, please just let me know. But in the meantime, how did the workshop go, and then what did you learn?